Hello everyone, welcome to this lecture on concept of expert system. In this lecture, we will discuss key components of expert system. So the expert systems are actually designed to emulate the decision-making ability of a human expert. So the human expert's knowledge will be utilized by the system to generate a necessary output, and this solves complex problems, but there are challenges in designing and incorporating the knowledge for the expert systems, because the knowledge collected for the systems may be incomplete or having ambiguous information, and the system uses knowledge, facts, rules, and heuristics for uh, deriving inference from the knowledge base. And one of the example of this system is Myzine. It is an expert system designed for medical diagnosis. This system uses backward reasoning. In this mechanism, usually the system answers why certain things happen. For example, in the system answers the question why the disease is caused, and how this bacterial infection is caused to the human, and also it recommends drugs based on the person's weight. Now let us discuss key components of expert system. So the expert system consists of knowledge base, inference engine, and user interface, explanation facility. The knowledge base is created by involving knowledge experts, knowledge engineers. They collect knowledge from the experts, and they formulate facts, rules, and knowledge information. All this will be stored in the knowledge base in the form of if-then rules. We have several facts described in some form. It represents the expertise of human specialist in that particular domain, and uh, so it is structured to facilitate efficient problem solving. The raw knowledge collected from the environment or from the people experts will be structured to facilitate efficient problem solving. The inference engine is the central part of the expert system, and this performs main processing on the knowledge stored in the knowledge facts and rules stored in the knowledge base, and arrives at a conclusion for the given query of the user. So this uses either forward chaining or backward chaining. Usually forward chaining answers the questions what will happen next or what will happen in future. For example, predicting the stock market, and it starts from known facts and arrives at a conclusion. Whereas backward chaining, when we apply backward chaining, we answer the questions why things happened, why certain things happened. For example, in medical diagnosis, so the system may answer the question why the disease caused, and what are the infections, and what drugs can be prescribed to the patient. So this can answer those kind of questions. So it starts from the goal and collects relevant facts, and determines which facts are relevant to the goal. And this architecture of expert system, you can see here we have users. Users may be unskilled users, they may not be having sufficient knowledge, so there is an explanation facility to answer the users why the answer is correct and why it is relevant to the query. And it gives suggestions and recommendations, and explains various queries with respect to their uh, answers, with respect to the answers generated for the query. And we have an inference engine at the central part of this system, so which makes use of a backward reasoning or forward chaining or forward reasoning to derive conclusions. So by using backward chaining, it starts with the goal and collects relevant facts and determines the relevant information, whereas when it applies forward chaining, it starts from the facts and arrives at a conclusion. So the knowledge base is constructed by involving knowledge engineers and knowledge experts, and this as part of the knowledge acquisition process. We pass queries and get the answers and refine the knowledge information, formulate some rules and also to create this knowledge base. And the user interface usually allows users to interact with the system. User can pass query and get the response what they want, response from the system. And in advanced systems, we may have a sophisticated UI with additional user-friendly features. The explanation facility provides necessary explanation about the conclusion, what has been arrived at, and how the conclusion is correct. It answers the query and makes the user understand how the system generated the results and why the answer is or the solution is recommended to the user. So that's on this lecture. So in this lecture, we have discussed concepts of export systems, including examples and components, key components, and various aspects of export systems. So domain expertise may be specific to domains, and when we gather knowledge about the problems and various scenarios, so there may be valuable knowledge, and we have to codify the experts advice. And there is a limitation in it because within a specific domain we may face challenges in collecting relevant facts or rules knowledge, and there may be ambiguous rules or knowledge and incomplete information. So this will cause difficulties when we build a system. So maintenance of the knowledge base requires periodic maintenance and continuous update, collecting experts advice. So these are time consuming process. So these are some limitations in this in designing and developing an export system. So export system plays various role, and it plays very important role in many fields. For example, in healthcare, for medical diagnosis and treatment planning, and for finance, it can provide experts advice like financial advisor can provide investment advice. In engineering, manufacturing, and it can detect the faults and prevent the failure. And for customer support, you can troubleshoot the issues and address customer queries and other issues. So that's all, guys. In this lecture, we have discussed um, what is an expert system and examples, key components of expert system, and other key aspects related to it, limitations and applications. So this covers the concept of export system in detail. Thank you.